Today we are going to be going through lesson 2.2, which is about solving inequalities. So last lesson we solved equations. Today we're going to solve inequalities. So we're going to go through the notation for inequalities first, just remembering some key things about how we represent different inequalities in different ways. The first inequality that we're going to talk about is x is greater than a. So the greater than symbol is what we use for the inequality notation. When we're graphing and x is greater than a, we use an open dot at a, and then we use an arrow to indicate the numbers that are greater than a on the number line. So those would be going to the right. And then finally, our interval notation. We start our intervals always with our smallest number. So in this case, a is the smallest number that's part of the solution set. And since a is not part of the solution set, it's just the numbers greater than it, we use a parentheses around the a to indicate that. So our interval notation goes from a to infinity, and then we use a parentheses around infinity always. Same concept here, but now we've got greater than or equal to as our solution in inequality notation. So when it's equal to, that's when we use this closed dot. Okay, still indicating all the numbers greater than it to the right with our arrow there. When a is included in the inequality, we want to indicate that in interval notation with a bracket around a instead of a parentheses, and then still going to infinity, all the numbers bigger than a, and using a parentheses around infinity. Next, we have less than. So if our solution is x is less than a, we use an open dot again at a because a is not part of the solution set. It's just the numbers less than it. And then the numbers less than a on the number line are going to be to the left. So our arrow indicates that. Now, again, when we're writing it in interval notation, we put the smallest number first. So in this case, when we're going to the left or less than, negative infinity is the lowest part of the solution set. So we start with negative infinity and we go up to a. A is actually the highest number in the solution set now. Again, it's an open dot. A is not part of the solution set, so we use a parentheses to indicate that. Finally, we have x is less than or equal to a. Since it's equal to, we use a closed dot, and we indicate that it is less than with that arrow to the left. Again, less than would start with negative infinity as its lowest part of the solution set in interval notation going up to a. A is part of the solution set, so we use a bracket there. Okay, so some key tips that we want to remember here when we're writing interval notation specifically is that the lesser number always goes on the left, and brackets never go next to infinity symbols because we can never actually get to infinity, so it's not something we can actually put a dot on the number line on, so we can't include it in our solution set. Okay, so some key things here that we want to remember when we're graphing our solutions to inequalities. We want to remember that we are going to use an open dot when the inequality is greater than or less than, indicating that the solution itself is not part of the set, and we want to use a closed dot for greater than or equal to and less than or equal to. When we're doing interval notation, for that open dot or for that number that's not part of the solution set, we want to use parentheses around that number. And when it's closed or part of the solution set, we want to use brackets around it. So those are the three main notations we're going to use to once we've solved our inequalities. And so now let's practice that a little bit. All right, so in these first ones, we are just taking a inequality, graphing it, and then writing it in interval notation. So first one, we've got x is greater than or equal to negative 2. So greater than or equal to negative 2. I remember from up above that when it's greater than or equal to, I'm going to use a closed dot. So I'm going to label my number line here. Let's go negative 2, negative 1, 0, 1, 2. So at negative 2, I'm going to put a closed dot. And then I'm going to indicate that the solution is all the numbers greater than negative 2. So I'm going to draw an arrow to the right to indicate that. So that would be the graph notation. And then for the interval notation, again from up above, I remember that since it's greater than or equal to, I'm going to use a bracket around -2. And then my solutions go all the way to infinity with a parentheses around it. Number 2 says x is less than 4. So again, on my number line, I'm going to put maybe 0, 1, 2, 3, 4. So at 4, since it's less than, I'm going to do an open dot, indicating that 4 is not part of the solution set, but all the numbers to the left of 4 are, or all the numbers less than it are. So I'm going to use my arrow to indicate that on the graph. When I write my interval notation here, my lowest or my lesser solutions go to -infinity. So I'm going to put that first, and then up to 4. 4 is not part of the solution set, so I'm going to use a parentheses around it. And then finally, we have x is greater than 0. So I'm going to put 0 on my number line, just greater than. So I'm going to use an open dot. And the numbers greater than 0 are to the right of it. So we could put 2 over here. We could put -2 over here if that helps. For my interval notation, my lowest number in my solution set is 0. I'm going to use a parentheses to indicate that it's not part of the full solution set. And then greater than would be going to +infinity. So that would be my interval notation. So those are some examples, once we have our solutions to inequalities, how to graph them and write them in interval notation. Next, we're going to talk about solving inequalities. So we have a few things to remember. First of all, when we're solving inequalities, we solve them exactly the same way as equations, except, and this except is really important, we are going to switch the way the inequality is facing if we multiply or divide anywhere in our solving by a negative number. So we're going to turn the inequality around anytime we're solving and we divide or multiply both sides by a negative number. So let's look at what that might look like. So for number 4, we're going to start it the exact same way. We're trying to isolate that x value by itself on the left side of the equation. So I'm going to start by subtracting 7 from both sides. That's going to leave me with 3x is less than 24. And then finally, to isolate the x, I'm going to divide out the 3 on both sides. Now I'm going to pause here because I'm dividing. I need to double check that I am dividing by a positive number, not a negative. And since I am, I'm just going to leave the inequality symbol alone. So that's going to leave me with x is less than 8 as my solution. It also asks us to write it in interval notation. So less than 8 would be going to -infinity. And my solution set goes up to 8, but does not include 8. So I'll use a parentheses there. The second one, we've got x's on both sides of the equation, and we've got constants on both sides of the equation. So I'm going to move this constant of 12 or -12 to the other side by adding it. So that's going to be 4x is greater than or equal to 7x minus 3. Then I'm going to get my x's together on the same side. So I am going to subtract 7x from both sides. That's going to leave me with -3x is greater than or equal to -3. And finally, I'm going to divide both sides by -3. Again, pausing to check, I'm dividing by -3. So since I'm dividing by that negative, I am going to have to switch my inequality symbol around. So now it's less than or equal to 1. Now my interval notation for this one, going to the left of 1 or less than 1 would take me to -infinity, up to that +1. It's equal to, so I'm going to include a bracket around 1. Okay, last one here. We're going to start by distributing that 6 into our parentheses. So that's going to give me 6x minus 54 is greater than or equal to 21 plus x. All right, now I'm going to get my constants together on the right-hand side. So adding 54 to both sides. That's going to give me 6x is greater than or equal to 75 plus x. Now I'm going to get my x's together on the left side by subtracting x. That's going to give me 5x is greater than or equal to 75. And then my last step is going to be to divide by 5 on both sides. So that's going to leave me with x is greater than or equal to 15. Because I divided by positive 5, I don't need to switch my inequality symbol around. This interval notation, greater than or equal to 15. So that means it starts at 15, including 15 with a bracket, and goes to infinity. So those are the steps in the process of solving. Let's talk about a couple of special cases. All right, these are called compound inequalities. So compound inequalities are where two inequalities are joined together, either by the word and or by the word or. Okay, so we're going to start with and inequalities. This means that the solution set is all the numbers that satisfy both inequalities in the end. So our answers have to be part of both inequalities in order to be part of the solution set. So for this first one, you can see we've got our inequality notation up here. -2 is less than x is less than 6. So if we separate that out into two separate inequalities, right here we have x is greater than -2, flipping that around so that we have the x on the left side. And then if we look at the second half, we have x is less than 6. So we are going to graph that here. I'm going to graph x is greater than -2. So I'm going to put -2 on the number line. Greater than is an open dot. And my solution set is going to the right of it. For x is less than 6, I'm going to count over to 6. At 6, it's less than 6, so open dot again. And my solution set is the numbers less than. So those two together are what make up that graph now. So what that's showing us is that all the numbers between -2 and 6 are part of the solution set. So you can see that in the interval notation. The solution set goes from -2 to +6. That's one example of an and inequality. In number 2, we're given the graph and we're given the interval notation, so we can see that the solution set is all the numbers between -3 and +4. So I start with my x in the middle, because I know they're going to join together, and I know that -3 is my smallest number, so that's going to be over here, and we're going to indicate that x is greater than or equal to it. And then we're also going to indicate that that x has to be smaller than or equal to 4, both equal to because they're closed dots on the graph. Next up, in number 3, we have a similar situation. So we can see on the graph how the solutions are between 1 and 5, 5 included in the solution set. So my interval notation, going from the lowest number, which is 1, it's an open dot, so I'm going to use a parentheses, all the way up to 5, which is closed, so I'm going to include a bracket. Number 4. In number 4, we can just see the interval notation. So I can see that my solution set is going from -4. So I'm going to count over -1, 2, 3, 4. It's a bracket, so it needs to be a closed dot at -4. And then it needs to be an open dot at 0. And the solution is the numbers between those two. So my inequality, again, I'm going to put the x in the middle. My lower number is -4. That one's a closed dot or a bracket, so it's going to be x is greater than or equal to that, going up to the x value of 0. All right, and finally, number 5 for our and inequality. This one looks a little bit different. We can see it's saying that x is less than -2. So on my graph, I'm going to put an open dot at -2 and indicate all the numbers less than it. And x is greater than 3. So open dot at 3 and all the numbers greater than that. And what we should notice here is that these two don't come together. There's no numbers in between -2 and +3 that would satisfy those inequalities. In other words, there's no numbers that are less than -2 and bigger than 3. That's impossible. So when that happens, we just say there's no solution. It's not possible to find a number that fits in those two inequalities at the same time. Okay, next up, we're going to talk about OR inequalities. So OR inequalities is where the solution set includes all the numbers that are part of either inequality or both of them. So it could include some ands, but it also includes things that are in either of the two inequalities separately. So if we look at this first one, we have x is less than -1, and we have x is greater than 2. So the solutions could be numbers that are smaller than -1, or they could be numbers bigger than 2. So on my graph, I'm going to indicate that with an open dot at 2, and all the numbers greater than it to the right. And then I'm going to indicate the other part with an open dot at -1, and all the numbers less than it. So this is where our graphs can point different directions with that OR, because the solutions can be in either part. On number 7, we can see our graph going two separate ways, so I'm going to write an inequality for each one. So for this one, on the left-hand side, that if I count over -1, -2, -3, -4, -5, it's at -5, which means my inequality is all the numbers less than -5. So I'm going to go x is less than -5 for that part. Then I'm going to say OR and do the other half of the graph that we can see there. So the other half would be all these numbers over here. So for that, I'm going to say, if I count over, that's 1, 2, 3, 4. So that's all the x values greater than or equal to, because of the closed dot, 4. Our interval for notation for this one, you'll notice, is a little different as well. Because of the two separate sections, we join them with a union in between. So on the left-hand side, I'm going from -infinity up to -5 with an open dot, so a parentheses, and that's joined with the inequality from 4, including 4 with the bracket, up to infinity. Okay, let's do a few more of those. On this one, we have, in our interval notation, the numbers less than -2 and the numbers bigger than +2. So on my number line, I am going to indicate +2 and -2. And then I'm going to say that at -2, I've got a bracket in interval notation, so a closed dot. So a closed dot there. And all the numbers less than it going to -infinity. And on the right-hand side, I've got a closed dot at +2 going to the right, or infinity. So my inequalities would be all the x values less than or equal to -2, and all the x values greater than or equal to 2, with an OR in between. Okay, number 9. This says x is greater than 4, so let's look at these. X is greater than 4. So greater than 4, if I count over 1, 2, 3, 4, open dot, going to the right. Or x is greater than 8. So 5, 6, 7, 8 is right there. Open dot again, and this one is also going to the right. So that means that the solution set is all the numbers that are in either of those, but we can see that those overlap each other. So we would say that the interval notation, the lowest number that it goes to is 4 with an open dot, so parentheses, and it goes all the way to the right. So going to infinity on this one. So this one doesn't have two ones because of the left one. All right, and then our last example of this, we have x is greater than -2. So here's -2, open dot, greater than, going to the right. And then we have x is less than 5. So 1, 2, 3, 4, 5 on my number line. Less than, so open dot, going to the left. When we do that, what we'll notice is that this less than 5 would go all the way to the right, and this greater than -2, or sorry, less than 5 would go all the way to the left, greater than -2 would go all the way to the right. So what that means is that every number on the number line is included in our solution set. So that means our interval goes from -infinity to +infinity, all the way to the left, all the way to the right. Okay, let's solve a few inequalities here that are compound. This first one is an OR inequality. That basically means we're just going to solve them separately from each other. So on this first side, I'm going to subtract 5 from both sides and get that x is less than 2. Or, and then on the right side, I'm going to divide both sides by -2. Remember from the front page, anytime we multiply or divide by a negative, we need to flip that inequality around. So x is greater than or equal to 5. So those intervals would go from -infinity to 2. And so I'm going to use my union from 5 with a bracket to infinity. The next one, this is an AND inequality. So solving the same way, we're going to isolate the x on this first one and divide by 2. So that's going to give me x is greater than or equal to 1. And on this other side, we're going to add 4. And divide by 3. So that's going to give me less than or equal to 7. That's an AND inequality, so it has to satisfy both of them. That means that the numbers greater than or equal to 1 and all the way up to less than or equal to 7 are going to be my solution set. So that's going to be a bracket around 1 to a bracket around 7. Finally, this one is a compound inequality joined together. So a little different situation. Since the inequality is in the middle here, and we kind of have a solution on each side, whatever we do to the middle section, we need to do to both the right-hand side and the left-hand side. So you're basically solving two inequalities at the same time here. So we're going to have -6 on this side, 2x left in the middle, and 8 on the right-hand side. And then finally, to isolate that x in the middle, I'm going to divide by 2. You need to remember to do it on all parts. So that's going to leave me with -3 is less than or equal to x is less than or equal to 4. So that means x represents all the numbers between -3 and +4. So my interval is going to be -3 to 4, both with brackets. Okay, that is lesson 2.2 on solving inequalities. We'll see you next time.